municipalities and industries are spending money to clean nitrogen and phosphorus from their water because they're being regulated to do so. So our business model allows us to actually produce really low cost algae because our capital and operating cost of our system is for water treatment. The algae is a byproduct.
Hello and welcome to the Pumps and Systems podcast. I'm your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today, we're going to be speaking with Dr. Martin Gross, CEO and founder of Gross-Wen Technologies. He's going to be telling us all about algae-based technologies and their role in the wastewater industry. So, without any further ado, let's get into the episode. So, welcome to the Pumps and Systems podcast. We really appreciate you being here. So, how are you doing today?
I'm doing well. Thanks for having me on today.
Thanks for being here. So today we're going to be talking about algae, specifically its use in the wastewater industry. But before we get into that, would you mind introducing yourself? So tell us about who you are, what you do, anything you'd like our listeners and viewers to know.
Yeah, my name is Martin Gross. I'm the CEO of GWT. We're an algae-based wastewater treatment technology company. It's a company that I founded around 10 years ago now. My background is I have two PhDs, one in biosystems engineering, one in food science and technology. And the technology we're commercializing is the one that I came up during my PhD work. So yeah, really excited to be on and look forward to the conversation.
Yeah, we're excited to have you. So how did you get into algae? Like, was there something that spurred you in that direction, or was it just kind of a lifelong love of green sea stuff?
Yeah, it wasn't the latter. So during my undergraduate degree, actually, I heard about algae, and at that time, take me back to maybe 2010-ish time frame, there was a lot of interest in taking algae and making biofuels out of it. So peak oil time, and the thought at that time was algae is the crop of the future. And I was sitting in a genetics class, and they're talking about genetically engineering algae and making all this fuel and making it so you don't have to pump oil out of the ground anymore. You can make it out of pond scum. And I thought that was pretty cool. So I actually reached out to a professor at Iowa State University where I was going to school that apparently was working on algae, reached out to him and said, hey, what's the story about algae? And he just said, hey, come to my office and we'll talk about it. Long story short, that professor is now the Wen in Gross-Wen. I'm Gross. I'm Martin Gross, so I'm the Gross part. He's the Wen part. So him and I end up working together for quite a few years now. But he was doing algae research at the time, and that's how it all kind of started.
So moving into our main topic of algae, so could you tell us a little bit about how microalgae are used in nutrient recovery?
Yeah, so happy to do that. So you can think of, first of all, is microalgae are single-celled microorganisms that are a lot like plants, but they're only one single cell. So algae, as they grow, they're taking CO2 out of the atmosphere. They're like a plant that needs nitrogen and phosphorus to grow. So just like a farmer would add nitrogen and phosphorus onto their crop to grow a good yield of whatever crop they're trying to grow. Algae also are like a plant where they need nitrogen and phosphorus to grow. So in our case, we're actually leveraging what they already want to do, which is eat nitrogen and phosphorus, and doing it in an application where nitrogen and phosphorus is actually needing to be taken out of the water. So it's really, to say it simply, algae eat nitrogen and phosphorus out of the water as it grows. And then to actually remove it from the system, you harvest the algae from the system, which will then contain the nitrogen and phosphorus, thus cleaning the water.
That's very cool. I didn't know that algae could do that, so it's good to know. So next, let's talk about something called algal biomass, and let me know if I'm saying that wrong. But so first of all, what is it? How is it created, and what can we do with it?
So what I would say is algae biomass is really, the material that's grown during the algae treatment process. So as algae is growing, it's dividing, it's getting more mass, and eventually you need to actually remove that from the system. And what we remove from the system is called algae biomass. And algae biomass is like other crops in that it can be made into valuable products. So if you think of like a corn kernel, that corn kernel could be fed to a cow. It could be made into ethanol. It could be, separated out and made into plastics and all these different things. And algae is really no different. So algae contains carbohydrates, they contain lipids or oils, they contain protein and other valuable compounds like nutraceutical compounds and antioxidants. So what we focus on when we grow algae on wastewater specifically is, algae is being grown on some pretty nasty stuff at times. So it's not very suitable for making a food ingredient, for example, or a feed ingredient. It wouldn't pass those regulations, and I don't think people would want to eat it, knowing it comes from wastewater. But what we do is we make it into products that are okay to be made out of wastewater products. For example, fertilizer. So our primary product that we're making the algae into today is a slow release turf grass fertilizer. So think of your home lawn or your favorite golf course. They spend a lot of money to apply fertilizer, make the grass green and grow well. We provide a product that could be used in that as a product for there. Our product tends to be very low carbon footprint, very sustainable, because again, it's coming from this microscopic plant that's general purpose is to clean the water. So fertilizer is the primary product today, but we're excited about a few others that are really under development. One is making it into bioplastics. There's several companies that are taking our algae and evaluating it to make bioplastics. And we also have a partnership with a large oil and gas producer where they're interested in taking our algae and making it into sustainable aviation fuel. So kind of where I got started, right, Tom, is I started this world of thinking about how do you make algae into biofuels. And long story short, it's difficult to do that in 2010. Better to treat water. Now we're kind of back there. It's kind of a full circle deal. So you can take the algae biomass that we produce and actually convert that into biofuels. And there's a lot of interest in decarbonizing air travel today. So you can make that algae into sustainable aviation fuel. So we have a partnership again with an oil major to do just that.
Wow, that's really interesting. So is that something like, is it just in the early stages of development, or is it moving along towards actually being like a usable thing, or?
Yeah, so I'd say somewhere in between those two. So since 2010, there's been continuous research and development on making algae into fuels. But the problem always has been the price point to grow the algae itself. It's an expensive crop to grow. So that's really kind of where our business model comes in. Is our business model is to provide the value in water treatment. Municipalities and industries are spending money to clean nitrogen and phosphorus from their water because they're being regulated to do so. So our business model allows us to actually produce really low cost algae because our capital and operating costs of our system is for water treatment. The algae is a byproduct. So really what's hindered this, algae to fuel industry from taking off is because the algae itself has been too expensive. That's been one of the big hurdles. So there's still some other development. How do you convert the algae cost effectively to the fuel? That's some development work there, but really our business model enables this process to actually happen now, but still probably years away.
It's still kind of a partnership between wastewater and, the fuel industry to a certain degree.
For sure, yeah. I mean, it's kind of a cool thought. Is a wastewater treatment plant, which is just considered a necessary evil to the communities, and of course, wastewater plants are now water reclamation and recovery facilities. It's more about recovering the energy and the resources in it, and we play really well with that. And is there a better story than flushing your toilet and knowing that you're powering an airplane flying across the sky? Like, I think that's going to be a cool place to be eventually.
So let's talk a little more about sustainability and things like that. So what are some of the climate benefits that we can gain from algae-based technologies, or tell us a little more about that sort of stuff?
So if you think about where the market that we're in, we are providing nutrient removal from wastewater. And usually the way you would do that is with bacteria or chemicals. Bacteria to do nitrogen, biological nitrogen removal, or EVPR for phosphorus, or chemicals for phosphorus as well, would be the common ways to do this. In both of those type of systems, they're producing a sludge, a chemical or a bacterial sludge that's a cost to dispose of. And if you compare that, and there's really not a lot of beneficial reuse of that product. We're making fertilizers and biofuels out of our algae, which indeed are sustainable products. And if you use the bacterial or chemical based method, you're not getting much value out of that. You're not creating other products out of it. It's really just a cost to dispose of. So there's just some sustainability story there, but really more important than that is the fact that we can remove nitrogen using a fraction of the energy that you would use when you use bacteria, which is a common approach. So maybe a third to two-thirds of the energy requirement. Lower energy, more sustainable. And our system is a low energy system. The others are really algae specific. So when algae grows, it's consuming carbon dioxide during the treatment process. When bacteria grows, it's releasing carbon dioxide during the treatment process. So when you use algae to treat the water, for every ton of algae that we produce at a facility, 2 tons of CO2 are taken out of the air. Pretty easy to actually account for this. So capturing CO2 directly from the atmosphere is a big sustainability benefit. And then the last one that I would note, in addition to the carbon capture from the algae and the reduced energy use, is the fact that we're removing nitrogen through a different mechanism than the bacterial processes. So when bacteria remove nitrogen, they go through nitrification and denitrification. They basically take ammonia, convert it to nitrate, and then send nitrogen gas into the air. So you're not recovering the nitrogen, you're just sending it to the air, which is all fine. That's how many of these plants have been run for years and years. But the problem with that is, one, you're not recovering the nitrogen. The second piece that's less known is that through the nitrification, denitrification process, you're producing nitrous oxide. And nitrous oxide is really potent greenhouse gas, over 270 times more potent than CO2. So if you're going through nitrification, denitrification, you're releasing N2O into the atmosphere, greenhouse gas. Now, if you're using algae, our mechanism is different. Remember, we're just eating the nitrogen. So if you eat the nitrogen, you're not producing the N2O gas that you otherwise would. Huge offset opportunity. That's one of the biggest greenhouse gas emitters from wastewater plants. That's probably the big sustainability story is reduce greenhouse gas emissions, creating valuable products like algae, and using less energy.
So, are there any recent advancements or new developments you can tell us about when it comes to algae-based technology, specifically in wastewater treatment?
I think it's an exciting time in algae-based wastewater treatment. It's a small group. Maybe there's 20 companies globally that are commercializing systems. But over the past couple of years, there's been some really important and large breakthroughs from companies from around the world. There's a company in the United States called Algae-Wheel. I think they've got 20 or so installations, commercial installations now. There's a company in Europe called iFike. They're having commercial installations. A company called Clearis is installing commercial systems. So where the industry still is quite nascent, there's really starting to get more and more commercial projects off the ground and demonstration that this technology isn't just a new fad or a research type project. It's actually making real impact in the industry now.
So then do you think that the algae industry is kind of a growing sector?
Certainly. And there's reasons for that. I mean, one of the reasons is there's stricter nutrient nitrogen phosphorus permits. So there's more demand for these products, but there's also these tailwinds of the sustainability. I gave you all the reasons why, maybe what I do is sustainable, but all the algae companies have that, have the same tailwinds. Our customers are municipalities and industries, right? But they all have a goal to be carbon neutral or lower their carbon footprint and really recover and reuse the energy and the nutrients. So these tailwinds work really, really well for algae systems. And I think that's really one of the big motivators for us.
And how do you think we can encourage more places to kind of give algae a chance or move in that direction?
That question probably is more tied to the challenge of any new technology being deployed in the wastewater space. Is no one wants to take risk. The engineers that design the facilities or the end user, or the owners of these tech companies and technologies, no one wants to take risk on new technology. And why would you? If you're in their shoes, why would you want to take risk with something new? What would help adoption is if that risk can be offset. And that's not an algae-based situation, that's any new technology. So that's probably the biggest thing that limits us and other innovative stuff that's going on in wastewater is it's hard to convince a risk adverse buyer to do something new because they're not motivated to do it.
That makes a lot of sense. Okay, so then how does the algae industry affect the economy, in your opinion?
The economy, that's kind of a tough question. I think probably I just simplify it to, the local site, the local facility that would be installed at. I'd say we've demonstrated, and I know other algae companies have demonstrated in the markets that they pursue, that it's the lowest cost form of treatment. So per pound of nitrogen to remove, what's the cost to remove a pound of nitrogen? We've demonstrated in a number of markets that it's the lowest cost way to remove that pound of nitrogen. So, from the local economy, that's this in the city that you're levying sewer fees on the residents. Like sewer fees will be less if the cost of removal is less. So I think that's probably the biggest impact. But you think a little bit bigger picture is, we're creating jobs, in our company, or these growing companies are creating, high-end manufacturing jobs. We have a really intensive R&D group at GWT where, we have 4 PhDs working on developing the next innovation within our business. So I think those are probably the two main flavors is the local, cost savings at the customer side, as well as, just the job creation and the new industry that we're creating.
So, speaking more generally now, what do you view as some of the top issues in the wastewater industry as a whole?
I think with the recent election, you could probably say regulatory uncertainty could be one.
Mhm.
For us, like I feel like it's a less of an issue for nutrient technologies. A lot of that's regulated at the state level, but if you think of PFAS and some of the regulations on these forever chemicals that are really, some of them are driven by the federal government. Like what's going to happen now in the next 4 years? So I think that's probably a big question that I don't know if anyone knows yet. But I think these things always come in cycles. So I think PFAS is a big one. I think the drivers for climate tech and sustainability in general, like where I say that we won't, like, the nutrient permits are unlikely to get, more lenient, but is there going to be as big of drivers for climate tech, with the new administration, or what are the incentive programs going to look like? So those are probably the big questions, at least that are on top of my mind. As you can imagine, those are the things that I think about quite often.
Yeah. Do you have any real life examples you'd like to share with us of like algae-based technology in action or any like memorable moments, any story you want to tell us? And if you don't have one, that's fine. But if you would like to, now is the time that you can do that.
Okay, well, this is a funny story. So
Mm,
let's see what you think of this. So again, we're deploying systems at wastewater treatment plants. Human wastewater goes into these plants, gets cleaned, and we're growing algae on that. You can imagine these, some plants are, you know, worse than others, odor, you know, visuals. But we're at a facility. I probably shouldn't name who it is, but we're hosting a tour, and the lady was going through the tour, and in our algae, we'll sometimes pull it off the belts, and sometimes it's pretty stringy, and it looks almost like threads. So I pulled some off one of our belts, and I was showing it to them, and they had gloves on. So I was like, you can want to hold it, and she was kind of playing around with it, and she took that algae and put it on her lip like a mustache. This is wastewater growing algae, and put it on her lip as a mustache. And I was like, probably better take that off. That's this is human wastewater, right?
Oh
So
no.
there you go. There's a story for you.
That's a good one. Yeah, and I think we'd better, protect the innocent in this and not name any names, but interesting. I mean, that would not be my first instinct with wastewater algae, but I mean,
It definitely caught me off guard.
all right. So before we close out the episode, is there anything else you'd like to share or any final thoughts you'd like to leave us with?
Yeah, just appreciation for having us on, and thanks for the interview. I would probably just say for the algae industry, like any other nascent technology in the wastewater space, is it just takes time for development of technologies. We've been doing this for about 12 years now, and we're finally installing commercial systems. And it's really an exciting time. It feels like the inflection point where it's been a grind for 10 years to get a technology off the ground, and now we're really seeing a lot of commercial uptake. So I'd love to come back on with you here in 5 years and kind of reflect on what has all happened. So thanks again for having me.
Yeah, thanks for being here. I'll pencil you in for 5 years from today, okay?
Send me the calendar invite. Let's go.
Okay. Huge thanks to Dr. Martin Gross for taking the time to speak with us today about algae-based technologies. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube page to see the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.